Okay, before we talk about the meat of this section, let's go back over some things with rational expressions. When we talk about rational expressions, we're talking about basically things that are fractional in form. Well, there are some things that we just don't do when we deal with that. Like for instance, we don't leave a negative in a denominator. It's just considered bad form. And if we were presented with something like this that was negative 5 over negative 7, then we could simplify that down to just 5/7 because a negative divided by a negative is a positive. Then also, we never leave fractions in unsimplified form, meaning if there is something that we can divide out of the numerator and the denominator, we should. So in this case, 6/8 should not be left like this. We have to say, well, 2 will go into both the numerator and the denominator. 2 will go into 6 3 times, and 2 will go into 8 4 times. So it would be much better to write it as 3/4. Okay, now you may be asking why we're going back over some of these basic fractional kind of ideas. And that is because this section is talking all about rationalizing radical expressions. Okay, if you were watching the videos from the last section of material, that was talking about adding, subtracting, and multiplying radical expressions. We didn't say anything about dividing. This section is going to be all about the dividing. Now, they don't really call it dividing radical expressions. They call it rationalizing. The reason for that is because when we write a division problem, which is all the fraction is, and we have a radical in the denominator, this then becomes an irrational number because the square root of 7 here is an irrational number. We can't deal with that. It's not good form to leave an irrational number in the denominator. Just like, if we have sign issues, we should clean that up. If we have common factors, we should clean that up. So same thing here. We cannot leave the denominator irrational. We have to fix that, and that's called rationalizing the denominator, making it rational rather than irrational. Okay, let's try and figure out what we have to do here. In order to make this denominator become a rational number, what we need to do is somehow we need to get rid of all of this mess, the square root of 7. We need to figure out something that we can multiply this by so that the number on bottom is actually rational. What our goal is we want to figure out some way to turn this into the square root of 7 squared. Now, why did I pick the square root of 7 squared? I chose that because the square root and the square are basically opposite operations. They undo each other. So we would then be left with just a 7 in the denominator. You want to try and figure out what you have to multiply by so that the index and the power will match. That way they undo each other. So now thinking about that, what would we have to multiply this square root of 7 by in order to get the square root of 7 squared? Well, we'd have to multiply by the square root of 7. Because remember, when we multiply radicals, we multiply what's underneath the radical. Now we can do that as long as we do it to the top also. As long as we multiply top and bottom, then we've actually only multiplied by 1. So 1 times the square root of 7 would be the square root of 7 on top, and the square root of 7 times the square root of 7 would be the square root of 7 squared. Now, finishing to simplify this, the square root of 7 on top, we can't simplify that anymore, but when we square a square root, it undoes that and we're left with 7. This now is a rational number.